Good morning, dear students. Our course name is Dynamics of Machine. I am Manish Kanodia, Assistant Professor in the Mechanical Engineering. Our today's topic is Gyroscopic couple derivation. Let us see the gyroscopic couple. The first question which arises in our mind is what is gyroscope? The answer to this question is it is a device used to measure or maintain orientation. It works on the principle of angular momentum and the initial axis of rotation is conserved. It consists of a spinning mass on an axis. You can see in the diagram there is an outer ring which is called as gyroscopic frame, and inside of this gyroscopic frame there is a gimbal which is again a ring shape, and a gimbal consists of a spinning axis and a rotor inside it. Now we will see the principle of angular momentum. So angular momentum is nothing but the product of mass moment of inertia to the angular velocity. For example, here we have indicated angular momentum as L and mass moment of inertia as I and angular velocity as omega. So angular momentum is nothing but a product of I into omega. Whereas if we talk about the linear momentum, it's the product of mass into velocity. So the linear momentum is denoted by the small v, whereas m is the mass and v is the velocity. We have represented this next term as just only for simple multiplication. So in angular momentum, angular velocity is considered, and in linear momentum, linear velocity is considered. Now we will see the derivation of the gyroscopic couple. Here you can see we are having an OX axis, and on this axis a disk is there. This disk is rotating in the anticlockwise direction when we see from this direction, that is from X to O. The axis on which this disk is rotating is called as axis of spin, and the axis which is perpendicular to this axis, that is OY axis, this axis is called as axis of precision. The positive z axis is called as axis of active gyroscopic couple, whereas the negative z axis is called as axis of reactive gyroscopic couple. The plane on which the disk is rotating is called as plane of active gyroscopic couple, and the plane perpendicular to this, that is the plane phi o z, is called as plane of spinning. The horizontal plane XOZ is called as plane of precision. Here you can see that if the small force is applied on this OX axis, this OX axis will change its position to OX dash with some angle, and that angle we have denoted by del theta. So if the axis is changing its position from OX to OX dash with some angle del theta after applying force, this will generate some couple or a momentum. So the momentum generated by this is called as active gyroscopic couple, and according to Newton's third law, every action there is equal and opposite reaction. So, opposite to this active gyroscopic couple, a reactive gyroscopic couple will be produced. Now, we will see some basics of this gyroscopic couple equation. Omega is called as angular velocity of the disk in radians per second. M is the mass of the disk in kg. K is the radius of gyration in meters. I is the mass moment of inertia of the disk in kg meter square. And the equation for this I is mk square. V is the linear velocity of the disk in meters per second. Capital R is the radius of curvature in meter, and omega p is nothing but the angular velocity of precision in radians per second. We know that omega is the angular velocity of the disk and I is the mass moment of inertia of the disk. So, the angular momentum of the disk is denoted by I into omega. Now, if there is a change in angular momentum, so the final momentum minus initial momentum will give you the change in angular momentum. So, OX dash vector minus vector OX is equal to vector XX dash. So, vector XX dash may also be written as vector OX multiplied by del theta, that is the change of angle. Therefore, change in angular momentum is given by I into omega into del theta, and rate of change of angular momentum with respect to the time is given as I into omega into del theta upon del d. Since the rate of change of angular momentum will result by the application of a couple to the disk, therefore the couple applied to the disk causing precision is given by C is equals to limit del t tends to 0 into I into omega into del theta upon del t. When we apply the limit, we will get C is equals to I into omega into d theta upon dt. Here, d theta upon dt may be replaced by omega p. So, the final equation for the gyroscopic couple is C is equals to I into omega p. Note that here the SI unit of gyroscopic couple, that is C, is Newton meter when I is in kg meter square. Now, you can see here we have represented this gyroscopic couple by the equation C is equals to I into omega p. So what is meant by I? I is nothing but the mass moment of inertia of this disk. Omega is nothing but the angular velocity of this disk. And what is meant by omega p? Omega p is nothing but the angular velocity of the precision, means the velocity with which the axis OX is changing its position to OX dash. Thank you.